Hey guys, I wanted to give you a quick tour of my machine today. I'm going to go through just the hardware mostly. I'm going to ignore the electronics for now. There's a lot of stuff going on there, so I think we'll cover that in a following video. But I've been getting a lot of questions, and so I wanted to put this video out there to just answer a lot of those. So mostly what I'll cover today is what is this machine, what did it start as, where is it now, what are we using for a hot end, cooling, and extruder system, as well as motors. So let's start with the cooling because I think that's pretty interesting here. I have two 60-40 axial fans here. They're capable with no back pressure of delivering 55 CFM each. So that's quite a lot of flow. A lot of people ask me why I don't use a compressor and then piping that directly to the nozzle. That allows you to direct the flow very accurately, but the issue with that is that you don't get a lot of flow. And so that's directly proportional to the amount of cooling capacity that you're capable of. So Q equals MCP delta T. So you can't really change the CP, but you can change the change in temperature and you can modify the amount of flow. And so it's very cheap to modify the amount of flow going across. And so that's what I've chosen to do. So I've chosen to change the M in that equation. If that went over your head, yeah, don't worry about it. And just know that the more flow you have, the more cooling capacity you have. Now, the compromise that makes, and the reason why that, that doesn't seem obvious to some people, is because I have these giant openings here. The design methodology for this entire machine is do everything fast. Print fast, move fast, innovate fast. And so I follow the Pareto principle on this machine because, look, I don't use it for parts other than speed printing. I have a trident, I've got a Mark III, I've got a Mini, and I have a Mark Forged over there for those sorts of things. So when I need a lot of parts and I need them quickly, I use those machines. This machine is just an R&D project at this point. Eventually, it will get there. I can print 20K acceleration on this thing, 400 millimeters per second, and get decent parts. But I'm constantly working on it and constantly changing things, and so it's just not feasible to have it set up for that sort of thing. So I follow the Pareto principle. What that means is you get 80% of the result for 20% of the work. The last 20% of the performance takes 80% of the work. You really have to do a lot of analysis, a lot of trial and error to get that. And so when I find something that works good enough, I employ it, I deploy it, and I move on. And when I hit a bottleneck, that's when I go back and I change my innovations, right? So let's say I wasn't having enough cooling with this setup right now. What I would do, and I'm just running speed benchies, what I would do is I would change this area here. I would taper it in to blow just across the benchy, something like that, right? That's super easy to do. I design these ducts in an hour. They're good enough for now. Cooling is not the major issue that I have right now, and so that's why they are the way they are. And a lot of the things on this machine are the way they are. So that's my cooling setup right now. There's some more magic that goes into this and some experiments that I want to run and some results and data that I want to collect before I post that sort of video, because I think it'll be really interesting for you guys. And I haven't seen anybody else do this before, so I'm really excited. You can see it in this setup, a little bit of a teaser. So if you know what you're looking at, feel free to post it in the comments down below. I will neither confirm nor deny until I post that video. All right, so frame modifications. So one thing that I found is, so I've looked at what and how input shaping works and the math behind it and what the different shapers do. And so the most efficient shaper is actually ZV, but it's not very robust. And what that means is that it's very accurate, but it's very fragile. So what you really need to do to take advantage of that is to have a frame, really like it's actually the entire system. It's not just the frame. but you need to have the entire system set up so that it really only has one resonant frequency and everything else is damped. And that's why you use more robust shapers, because these machines, especially when they're just printed parts bolted together with 1515 or 2020, they have a lot of different resonances. And so by going to a more robust shaper, what that allows you to do, like MZV, or even further from that is EI, 2-hump or 3-hump. It's basically like a wider net, but imagine that it has wider meshes in it, wider squares in the mesh, right? So you can catch more stuff, but it's not as efficient. You're maybe only going to catch 90% of your fish, 95% of your fish. So what I've tried to do is I've tried to massage the resonance of this machine, and I've done that by adding side panels here that I actually printed on the trident over there, which is pretty sweet. And these have actually drastically changed the resonance of the machine. Oh, hold on one sec, real quick. Let's step back. So why the heck do we care about going with a more efficient shaper? Well, it allows you to reduce the smoothing. So if you have done an inch shaper before, you know that there are really two outcomes from it. 2 parameters, and those are vibrations, which is the residual vibrations. So let's say you use a shaper or you put it in the wrong place, you'll have some residual vibrations. You'll still have some ringing. Maybe it'll take out 80, 90, 95% of the vibrations, but you still have some. The reason why we don't want that is because that actually inhibits how fast we can go and the accelerations that we can do. So we want 0 vibrations. But when you start to print at 6 really isn't an issue, but like 1,000 or 1,500 or 2,000 millimeters per second, you really start to notice the smoothing effects. So the more robust of a shaper you have, the more smoothing it has of corners. And the simplest way I can put this is if you have a sharp corner, it now becomes a radius. But you see that effect in other places. So I've tried to do a bunch of tuning of the resonant frequencies of this machine, so that way I can use a more efficient shaper like ZV or MZV. So what have I done? I've done these side panels, like I said. I have some small corner gussets right here. They're just printed brackets, and they just bridge this gap right here. Silly little things like these are, what do they call these? The top hat brackets. And these are just, I've changed them so that they're really like an interference fit with this idler guide right here, so that they're pressed in really tightly, and then they're bolted into this top rail right here. And for that, I've actually been able to get, I'll just quickly discuss some of the changes that enabled me to make. So without any of those changes, and no side panels, I had to run, if I wanted to run MZV, I was only able to get, it recommended to get an acceptable smoothing parameter, I would have to run a maximum of 2,000 acceleration, which is absurd. And I would have 15% residual vibrations. That's awful. That's terrible. And so through some trial and error, I found that by adding side panels or putting on the top hat, I was able to modify the resonance of the machine. As much as I would love to have the top hat on there, I found that it did impact my results positively. It's a huge detriment to the cooling. And we'll go through that more in a follow-up video when I actually go through the details of what this cooling system is and how it works, and where the air flows and how it flows. But I found just by adding those side panels, I was able to bump it up to being able to use MZV, 0 residual vibrations, minimal smoothing, and a maximum acceleration of, I think it's like 26,000, which is okay. I mean, I'd like to see it a lot higher than that, but when you're working with a 1515 aluminum frame and printed parts holding it all together, you can't really expect much. So another thing I've done is I've tried to anchor it to the table, so I've just bolted it to this cheap IKEA table. It helps. Really, it doesn't change the frequency of the machine, surprisingly, but it does keep it from walking away. I don't have to hold it with my hands anymore while I'm running speed benchies. All right, so those are the frame changes. Hot end. I'll quickly go over this. Actually, let's include this. Let's just make this the XY gantry right here. So on the XY gantry, a lot of changes have been made to make this far, far, far lighter. With stepper motors, in general, you have a given amount of torque that they can output. And so what you care about is you care about accelerating this as quickly as possible. And so using Newton's law of motion, we have F equals ma. And, right, so we have a given amount of, well, torque is just force times a lever arm. Our lever arm is constant, so let's ignore that. So let's just say that these motors can output a constant amount of torque, constant amount of force, excuse me. So we have F equals ma. Our F is constant. We have our mass and our acceleration. We want acceleration to go up. So what do we have to do? We decrease the mass. So it's critical that we're decreasing mass here. And it's proportional to acceleration. So if I can cut mass by 50% here, I can increase acceleration by 50%, and I found that to be true through my own testing. So a lot of little things in here. Material choice for one. I've gone with ABS. ABS is, as much as I love to print PETG, and I know a lot of people love to print PLA, ABS is like 15% lighter per volume, and so I've printed everything in ABS. I've also gone to a Bowden system. This was originally a V0. I converted to a V1, and I started to get into like around the 6-minute mark with direct drive, and I got really tired of that. I wanted to go a lot faster, so I went to Bowden from there. But I still like the architecture of the V0.1 head, and so that's what I've tried to maintain here. So what I have is I've got a custom sort of like adapter here, and then I have obviously my extruder on the back of the machine, but this allows me to hot swap extruder types. So if I want to go back to a direct drive, it's these two bolts, take this thing off, plug in the cartridge on the back, just like the V0.1 has, plug in the stepper motor, and we're done. And so that's one of the biggest things that allowed me to cut the weight by like 40%. Another big thing was removing the part cooling fans on the side. I don't need them now that I have the RCS here. I still do need this fan. I've done testing with trying to remove it and simply have an exposed heatsink and try to have the airflow just from having the head move so quickly, cooling the hot end, but that it is just too finicky, and I don't have the patience to deal with that. Big changes to the cowling here, removing the part cooling fan, hot end development, a lot of magic went into that. The setup that I have on here now is capable of going, I don't know, probably to 450C if I really, really, really needed it to. I don't want to do that. But the hot end that I have here is like 30% lighter than a stock Dragon, but it can flow like a Magnum Plus. So I'm capable of going at 250C and with ABS. I'm able to go up to 60 cubic millimeters per second. But if I really push up the temperatures, I think I'm probably around like 80 or 90. But the big thing again is lightweight. So I've cut the weight significantly. This tool head, I think weighs around, with hot end, everything. If I was to remove this and the mounts and everything back here, I think I'm at like 85 grams. So that's huge. Another big thing is I have replaced this crossbar. So instead of this being 15-15, what I have is it is actually a printed beam, printed in Essentium CF25. And I've been able to cut about 20 grams by going with that. That stuff is really stiff, which is great, but it's as long as the resonant frequency is matched throughout the machine, then it doesn't really matter how stiff it is. So if the resonance of the system is, let's say, 75 hertz, and the stiffness of this beam in this configuration is also 75 hertz, I don't care because it'll be taken care of by input shaper. But if this caused a secondary frequency around 25 hertz, that would be no good because I would have to be using a more robust shaper and I would sacrifice quality. Where can I go from here? I've also done the mounts back here in Essentium CF25. How much those help, I'm really not sure. I can cut probably another like 7 grams if I were to change these to ABS, but you know what, they work good enough right now. To cut another couple percent off would take a good amount more time. You know, it would probably take me 2 hours, to be honest, and it's just not worth it. There are bigger gains to be had elsewhere. Motors. All right, here's the big thing. So I am running 48 volts, and I was running the NEMA 14s, the LDO NEMA 14s that are 48 millimeters long. I think the part number is LDO-35STH 48-1684AC, whatever. They're really, really good. So they didn't skimp on the windings, and so they have really low inductance, but actually pretty decent torque. And so what that means is they actually have a lot of speed before the back EMF starts to overcome the drive voltage. And so those are fantastic motors. But I ran into a bug in Clipper where I actually shut down my Pi and the motors stayed powered, and one of them actually ended up burning themselves out. And so I was about to order a new one, throw those back in here, and I thought to myself, you know what, I'm really impatient, let's just design new mounts. So I got new mounts designed in about an hour, printed these in about 2 hours. Ignore the skipping on here. I needed to increase the drive current on my trident for the extruder motor, but they work. And so now what I'm running is LDO 42STH 48 2504s. So these are pretty much the best motors that you can get on the market. It's arguable whether these are better than the E3D Super Whoppers. I think the Super Whoppers might be capable of more speed if you gear them down. So I actually haven't been able to do a run on these because I don't think I have enough power in my power supply. But that'll be a whole nother video. I think that's going to be able to help me maybe break 2 minutes and 30 seconds. All right, so what else? This started life as a V0, Formbot V0 kit that I bought last February with the intention of doing a 10-minute benchy. So it started life as Bowden. I since went to direct drive when I upgraded this to V0.1, and now I'm back to Bowden. Only changes to the motion system really are this rail. This is a CNA, which is a vendor on AliExpress, medium preload rail. It seems a little bit tighter than the Formbot kit. I really don't have that many complaints about the Formbot kit. Everything seemed fine to me. I did an unboxing on this channel a while ago. If you go to my videos and you sort by views, it's probably the one with the least amount of views. I think it's got like 15 views or something. It's pretty boring, but I go through all this stuff in detail. Genuine Gates belts. I think that's about it. I can go through this. So I do have a 70 watt heater here on the Hotend, and I use a PT1000. I use them on all of my printers now. They're quite a bit more expensive than just like the typical Beta 3950s, but I'm always, on almost every printer, I'm going above 290C, and so I just install it from the get-go. They never give me any trouble. Yeah, so I think that's it as far as the structure for this and the general printing and extrusion hardware. Oh, the extruder. So on the extruder, I am using it's just a 48 millimeter NEMA 17 with Bondtech gears directly mounted. So there's no additional gear ratio, simply because I'm lazy, and it's cheaper this way, and I don't need any more than that. That system is very capable of stripping and grinding through the filament. So, yeah, could I have gone to like a 7-to-1 or a planetary gearbox or a 3-to-1 BMG setup? Yes, but it would cost me $30 and it doesn't add anything. So I just took the Bowden gears, mounted them to the extruder. It works. It stays cool. And so that's that. All right, I think that's all I've got here. We'll go through the electronics another day. That's a whole another nightmare. If you have any questions, comments, insults, leave them down below.